Welcome to another Tech Talk with Johnny Sanders. Today's Tech Talk is going to be about building a cloud that's ready for application architecture. Okay, this is episode 17. So let's sit tight, sit back, relax, and let's just enjoy this discussion. Again, truth in life, in my experience as an IT professional, I just want to share some of my experiences with building applications within the cloud. And again, you can use these messages as a guide to help you in your profession, you in your skill set, you in your activities with building applications in the cloud with your company. Okay, so let's get started. Anyone who has built an application understands the applications are designed specifically for that particular platform, whether it's Microsoft, whether it's Oracle, whether it's AWS, whatever platform that is designed to run on that to help make things run, work better for resiliency, efficiency, faster speed, managed applications for the troubleshooting that may need to be done or required to do if something goes awry. So you want to be able to do this and develop it in the public cloud and the private cloud platforms. Simple as that. Platform specific designs. Okay, we're going to start off with number one. Applications built to leverage the specific features and capabilities of specific target platforms, as I just mentioned, would generally offer superior performance. You will see that once you get those applications on that platform, you will see a significant change in the functionality of those applications, of less downtime, right? Speedy recovery. You will see the benefits of that very quickly in these particular types of applications. So they will also show you the resiliency of how well they handle setbacks, failures, scaling up and down. If the application demand more people, more data is being put on it, you will be able to scale up, and you will easily be able to scale down if you're not utilizing it that much. So keep in mind, especially for AWS clients, you pay by the usage. You scale, the more you use it, scaling up, the more you'll have to spend. The more storage, the more data, the more you will have to spend. So just keep that in mind when it's time for choosing which program you're going to go with. Okay. So, cloud platforms. So the principle of platform specific design applies equally to cloud environments. So depending on your environment will determine the type of cloud usage you're going to have. Now we have hybrid cloud, we have on-premises applications that will use certain functionality of going into the cloud, but it's more or less on the prem where that particular data will be stored. On premises, okay, versus full cloud. So whether it's public or private, you will have to determine those particular principles for that specific platform. When you're developing applications on that particular cloud, keep in mind that you need to lead with an understanding of expecting a better performance. You need to be communicating this in your meetings, in your IT meetings, in your functionalities to explain to management that this is going to make the application run better, is going to make their jobs easier to monitor and to manage, and for even the engineers to basically put it together and develop. Okay, so let's talk about development for a minute. Practical implications for development. So Most developers, I'm not going to say all because I don't know everybody's background functionality, but most developers have a principle where they basically try to get a good understanding of that particular application, um, a good understanding of that platform before they start speaking or directing a company or department or business of using certain applications, um, and understanding their capabilities, right? Good engineers try to understand what that application can do and optimize the performance to its best peak production. So they may have to tailor certain applications to exploit the platform's best strength, such as specifically, I want to talk a little bit about APIs. APIs or program that I've used before. It's a service that I've used before to help businesses reach their optimizational performance level on a high standard. So API is application programming interface. So it is a set of rules that the application has to follow. The program follows this and basically communicates back and forth with uh, one platform to another, sharing specific data and allowing maybe two departments, three, four departments function with one particular application by using APIs that will basically send data back and forth. Um, and it depends on the software type, of course, that you have to go back and forth. Anything that involves a computer code, such as operating systems, software libraries, and web applications, will be utilized with APIs and provide great functionality. So in this design, the engineer would basically focus on designing the service, the modular, reusable tools, and interoperable uh, mechanisms that will be able to allow the software to flow and function smoothly. Another good thing with a good practice is to document what you've basically implemented in someone's platform, their program, their software usage. So you want to be able to ensure that they're able to use the service, use the software, use the applications as designed. Okay. You want to have standard compliance, using standard communication protocols to ensure that it operates at its full capacity. All right. When you're getting ready to implement, put together, utilize, and I'm using these words specifically so you can prepare the business for practical implications, practical migrations. Strategic planning is key. Again, with the documentation, you want to plan out what you're expecting or planning to do. You want to choose your platform, have everyone in equal agreement and understanding that this is the platform we're going to use. Getting the cost estimates is also key and valuable to communicating what we're going to do to upper management, to the executives, to the stakeholders of what this basically application software program is going to basically help the business uh, perform well and reach its specific goals, right? Once you do this and you want to put together some form of standard operating procedure, training manual that you will be able to basically show and invest in training for the best optimal use, again, once it's been developed and implemented on your particular platform. So users will be able to comfortably use this software and continuously working. So for cloud adoption, you want to communicate across the board what that cloud name is that you decide to go with, and you want to do some evaluation of that cloud, and what it offers, whether you're using public cloud or private cloud. You want to do an assessment of what that service is going to be for that group. Okay, when developers are designing the cloud, they want to develop the application with the cloud specifics featured in mind, such as auto scaling, managed services, and security practices. I can't speak about security practices, and usage and guidelines is very critical with so many hackers are out here that are trying to get people's data and get their information. You want to make sure that you're having steps and things in place so protocols can be followed. So again, with doing the cloud development, I would like to just again mention the software development lifecycle for developing applications. Okay, you want to analyze basically the business, what the business wants, what you can produce and deliver from a technical standpoint, right? You want to be able to meet with engineers, architects, and see how would this design look? What is going to be the functionality? How are we going to manage, maintain, check for security protocols, and all that great stuff, right? Then development will take place where you will have the front end development for UI usage, and back end development for how packages are going to come into that particular application, utilized for the best functionality. Then once you get it developed, you want to do a testing. So we have had a sandbox where we would test on the back end. It's always important. I've always had test environment. I've never had an application or an environment where we just develop something and put it in production. You asking for disaster if you do such a thing. So testing that particular software application is vital and crucial. Okay, you want to get with your architects, your quality engineers, your testers, your DevOps engineers as well, and say, hey, we want to plan a certain period of time, certain functionality. You want them to try to break it if they can, but also having users that actually use that particular application, make sure that they're able to continuously go and see the software applications functionality, its delivery, whether it's reporting, whether it's financials, whether it's financial statements. You want them to be able to continuously function as normal, as usual. So once everything has been agreed upon that it's functioning well, and I laugh because I've had many projects where once we've done the testing and the application was developed and designed and put together the way that the specs and specifications of that design was requested by the business, they would come back and say, oh, you know what would be good? We always want to be able to stop going to this database or that server because it takes too long, too many people utilizes it. We want it to go on this database. Code change, right? Just point where it needs to go, change the script. But what if we want to be able to also, in the financial statements, pull our general ledgers, our our um, our daily feeds of the how much money we've basically accumulated. We want to be able to show debits on this side, expenses and credits on this side, um, not just a total sum of the money. We want to be able to see and report the usage. So we had to go back and fix that in parallel, in agile activity, because we were at the finish line and this is ready for deployment to go into production. And now we're going to have to do some more development on this particular application. So what I suggested is, hey, we can give you what you're asking for. Let's deploy this into the production area. You utilize it as built. Give us an additional time, whether it's going to be weeks or months, depending on the extent of the application and the development that is going to be taking place. Once we come into that agreement, basically we would just all agree again that these new activities would be developed for this particular application of software, and we would move forward. So when developing applications as an architect for the cloud, you deal with complex distributed systems all the time. You have to, again, try your best to understand what the application is doing, take advantage of the good information that you can. You have to decouple the application from its current platform in a lot of cases that I've had to do. And decoupling means to basically remove it from its current system or platform so you can basically get access to that application and design it the way you want it to go. Okay. You can separate the application services physically um, through, the proper channels for services like API. Again, the API managers and governance technology that provide services directories can help track the many services that make up an application. Okay, so to adopt something called adopt SOA principles. Okay, to adopt SOA principles, this is to focus on building applications with services oriented mindset. Services oriented application basically ensures the service is basically decoupled and put in its independent state where you can leverage the application easily. So as a engineer, you want to use API um, services to the best of your ability. You want to be able to design it to where the APIs is exposed for full core functionalities, which can be used to build composite services and applications. Modularity, strive for modularity in application design, which allows for easier maintenance, scalability, adaptability to certain changes, right? So, practical implications for the business when you invest in SOA training, provide training and resources for, again, those users that's going to be using the application to the best of their ability. You want to just equip them and provide this information so it'll be something that they can easily grasp and use, right? So when you're preparing for cloud development, going into the application development, you want to be able to, again, have a good cloud strategy and basically leverage the services to make it easier for you as an engineer. You want to utilize what is provided, manage services and APIs to build and ensure applications are built properly with the flexibility and scalability in mind. Okay. Deploying your particular application in the cloud is a collection of cloud services. So, following these specific principles, service oriented architecture leads to more flexibility, scalability, utilizing it in a way that will help engineers maintain and provide good maintenance and stability for that particular application. So, focusing on the independent ability of these applications, the services and development makes it easier for installments, usage, maintenance, cost. The cost usually is better once you're using the cloud as a whole and getting in a good cloud platform as a service. So that way you can focus on the savings, but then good businesses utilize their savings to see how we can pour back into the business, pour back into the company, and even expand on their software application. Okay, this will allow them to continuously grow their their business as they continuously build on their cloud application usage. Next, we want to talk about integration solutions for digital transformation using, again, APIs and moving your applications and data into the cloud. So, integration solutions have played a major role in allowing organizations to digitally transform and ultimately create exceptional customer service just by having a better software application. So, one of the challenges for IT leaders when they're putting together a team of engineers, architects, designers, developers to utilize their particular application and putting it in place for many, in my experience, you have to figure out which integration solution will most efficiently work and connect with that particular application. You can't just use any old thing. um, as an engineer, one of the things you learn, in my experience, one example, I used a OpenShift application, using ETL. Okay, and I've shared a little bit before about using this ETL, basically transferring data um, in a batch file. So we had multiple databases, SQL databases, flat files that would basically send files to um, the ETL staging area. And it was done using batch files. And once it would go in the staging area, the system would basically compile and configure all the data to be formulated so it's one format, if you will. And that data is then transformed and then sent in another batch file to the data warehouse where it would be loaded and utilized, visualized, and seen. Okay, so that's one example. Another example that I've used in my past experience is MuleSoft, which is an API software platform application where you can basically use it to help you as an engineer to use on premises legacy data to perform integrations to mixed systems, okay, if you will, multiple systems. This service enables applications to function across the whole entire enterprise of the technology world, the computer world, the business world within your company, and the connection of even a partner's ecosystem, if you will, right? An API led approach to increase development speed, um, to have a competitive advantage. So I took some notes, and I'm going to read them because I don't want to mess it up. But this is um, a company that I used on a project. Um, so I won't give their proprietary information. I do want to just share with you that um, I was able to take modernization of legacy applications from an enterprise application into cloud native solutions on AWS. Number one of the things that I did was look at the legacy mainframe data, where this data would go into the Dynamo database, which is where the historical data is stored, backup data to an S3. S3 is a bucket in AWS. Lambda functions would go to operational store, basically grab that data, grab that information. Those particular records would basically be accessible via the MuleSoft APIs, what we have put in place, configured to basically go here and grab that data. Um, it would grab those records through web services. Next, the Lambda functions would take data out of the operational store and feed the data downstream to Redshift instance. Redshift is a data warehouse, okay? Redshift instance data would basically provide the sales and marketing team their data so they could be able to view it in a specific dashboard the way that they wanted it designed and decorated. And they would see the revenue frequencies, loss, gain, quickly at their fingertips. They would use more CPUs and more Amazon um, data storage, would, of course, as I mentioned before, would increase the charges for using more data on AWS. At this point, you have to basically talk. What I had to do is talk to the business to say, hey, are you okay with these charges? And it depends. If it was minor charges that increased, but the data, you have to weigh it to see if this was going to be something that is beneficial for the business. And in my particular case, one of their options is pay as you go. Um, and again, if they were planning on data fluctuating up and down, hey, pay as you go and use the service. Still, no waiting, and it's going to scale up and down for you automatically. And that was a specific project that um, I utilized MuleSoft for this particular company. Okay. Um, we used APIs to basically integrate this data, and myself and other engineers provided end-to-end connectivity and communication within this software usage. Okay. So, um, as an IT analytical leader, it allowed me to basically communicate, overcome challenges that we were faced with by using an old legacy application. But it benefited the company as a whole, the department as a whole. Financially, we were able to save money and use a multifaceted platform that was complex but able to handle large data and moving data from one application to another quickly, safely, secured. And that's the main thing that we want to be able to do. So once I was able to get this completed on for the project, so I did an evaluation of what was done, um, made sure that the needs that we discussed were identified and strategized and comfortably completed to where the department was pleased. They can sign off on the finished product, provide their approvals, and another successful project under my belt, but another successful project for the company, um, where we were able to do work quickly, sufficiently, effectively, and providing integration with new technology that was basically something that was a farce at first because they were using legacy old data to do their functionality. Now, they were able to get the work done, but there were, of course, the more human activity, interaction that you have, there's more chance for errors, mistakes. We're human. We make mistakes, and then especially when you're in fast pace and people are trying to rush and push you to do something outside the norm quickly. And if you're doing it on a regular routine basis, then you're comfortable. But what happens when you have a rush item or several rush items and you have to figure out, do it sometimes on the fly, and you're unable to do it, complete it, understand it. And sometimes you make mistakes. That's been what I've experienced. I've made mistakes. Other people that I've worked with, other engineers that I've with, have made mistakes, and then we got to come back and fix it. We got to correct it. Um, there was a time where I didn't enter all the necessary keys in a program for security's sake. I entered two, but there was actually a three-step program that I wasn't aware of. Not making any excuses. You do your due diligence. You try to get all the information. That's how I was able to know about the two security keys. The third one was further down the line around the back end, that once application, once data got to a certain point, it went through the security walls, firewalls, to pass and know that, okay, checkpoint A, checkpoint B, everything went well. They had one final checkpoint C that was going to send the data to the data warehouse, and that's where um, I had to go back and do some more research to figure out what happened, why did it happen, um, whose responsibility was to share this information, or was it documented? And long story short, it wasn't necessarily documented in a process flow. Okay, and that's how it fell short on my end. Once it went to another department, that department basically, to do their security checkpoints, they would take it from there. Well, it was in their documentation, but it stopped at this particular point at checkpoint B. So, anyways, that's been my experience, and one of the things that I was faced with when integrating solutions for digital transformation and basically working to use the best approach in applications, APIs for software development and moving data into the cloud. All right. So there you have it for today's Tech Talk. I'll do another one here soon. And I want to say thank you for joining me today and joining my discussion with putting these applications into the cloud. And again, hit the like, hit the subscribe, share the video, and I will appreciate it. Again, let's be good and let's dare to be great. See you next time.